Major differences between these two?
The middle point, or the middle area is not used, and brackets.
And what about the last one? What's the major difference between G and H?
You divide by the square root of all?
You what?
You can't have it negative and you can't have it zero.
Can't have it negative, which is the same as this. This can't be negative, but this one could be 0. This one cannot be 0. You can take the square root of 0, that's fine, but then you're trying to divide by it. And that's not allowed. So shouldn't this be the same thing, except x squared minus x minus 6 just bigger than 0, not equal to?
Yes.
And so the only difference in the work is that these 2 points are not included.
So the only difference is
It's open intervals.
right. It's a parenthesis of a bracket.
Yep. Negative infinity to negative 2, union 3 to infinity. All right, I hope that all makes sense. This is a review, so we can't get too much deeper into that. We okay?
Yeah, but it breaks the bills.
Functional composition. I give you 2 functions, f and g. I ask you for f of g of x or g of f of x. Do we want to see one or not? No? Okay. Find the inverse of a function. I give you a function, you find its inverse. That's the one where you replace f of x with y, you switch x and y, and you solve for. Let's just at least set one up, because I think y'all did okay on that on the test. But it was one of the I always seem to, no matter what, put a trickier one on there. Not on the final, but
On the test?
on tests I always like to do a little rational one like that with linear on top and bottom, because it was that special type of thing you have to do. Let's just work it. Make sure you can do it. Replace f of it. Oh, find the inverse, right?
Yeah.
Find f inverse. So I replace this with y. Then switch x and y, right? Everywhere I see a y, put x. Everywhere I see an x, put y. Then what?
Now you need to get y out of the denominator.
Yeah, we got to solve for y now, right? Solve for y. Multiply both sides by y minus 3. So x times y minus 3 on the left. And on the right, you just get the y plus 4. And this is, again, some people got hung up on that test when I asked you for this.
I remember that.
Distribute. And then what? Not yet. Not yet. This is where people get hung up.
This is where you
Oh, you
combine
pull out
like
the y, you pull out the y.
Yes, not yet though.
move it left over.
I have to get all the
Y over. Okay, so
yeah, so
we subtract the y and add the 3.
Oh, subtract x, y.
you got to get all y terms on one side.
Yeah.
Your choice on which side though.
Yeah.
Mhm.
swap 'em, you know. Put those-
And
put
and
that
then
X on
and then
the
what?
other side, make that negative positive.
And then add the 3x.
Not quite. You can't do that.
Add the 3x.
Minus y and
If you bring the 4 over here and divide by y,
Oh,
right?
Why would you?
You have to get all the y's on.
Yeah, let's get this negative 3x to that side, bring this y over. So subtract it. That's it. And what's the whole reason of getting all the y's to one side?
Factor that y
You can
out.
pull the y out.
Divide by x.
Okay. And then divide by, not quite x.
Alright, you know what I mean. the
Yeah,
x.
okay,
The
by
the x variable.
yes. Okay, so you're going to now divide by x minus 1 on both sides. That's your inverse function.
I remember that one.
Okay? All right, expanding and condensing log expressions.
That one.
Do y'all remember that?
Oh yeah.
Are we going to practice? You just tell me. If you want to see any of this, I can do it. So expand, condense,
I did do a lot of that.
vote.
I would like to see one.
You would like to see one? Yes? Okay. I'll do one of each. Expand log base 4 cube root x squared times x plus 1 over 16 times x minus 3. I'm trying to make it ugly so that, you know, it's kind of like if I beat you real bad today with a problem, then on the final it won't feel so bad, right? Expand this out. So what do you have to do?
You need to break it down.
Yes. How? Okay, you're gonna look at the cube root first, right?
Yeah, you're gonna.
As all of this to the 1/3 power. So I'm gonna rewrite the whole thing.
Put all that and bring it to.
All of this to the 1/3, not 3, right? 1/3. And that's going to allow me to take the 1/3 on the next step and
Put in the front.
drop it out front. Good.
Is it okay if we just keep that?
Oh yeah, you don't have to rewrite it as 1/3.
Okay.
You could just on the next line write this.
And so since there's a 2 dividing, we then do the 1/3 log 4, and we split those 2 for 1/3 log 4 with the x squared plus 1 minus.
Yes, you have division of two things inside of one log. It turns into 2 logs with subtraction. The 1/3 has to go to both logs. So you've got to have the 1/3 log base 4 of everything up in the numerator minus the 1/3, like I said, comes along, log base 4 of everything in the denominator. Make sense?
And then we have multiplication.
Now you have multiplication inside of a single log here and multiplication inside of a single log here, which means that you can split those into 2 logs with addition between them. The first one is going to be pretty clean. We don't have to worry too much about it. The 1/3 is going to come along again.
Well, that's going to be 2/3 log 4x.
It will. Yes, it will. That splits up into 2 logs with addition. The 1/3 has to go to both. The tricky part for the next one is what? What's the tricky part?
Making sure that you distribute that negative.
This negative 1/3 has to distribute to both. So you're going to have a minus 1/3 log and another minus 1/3 log. 1/3 log base 4 of what? 16 minus 1/3 log base 4 of x minus 3.
That's going to go to a 2 for that third one.
Yes, good. Got a few more things I can do here. I'm not quite done. What can I do on the first log expression? Bring the 2 out front as multiplication. 2 times 1/3 is 2/3. Log base 4 of x. On this one, can I do anything? No, right? I cannot split that into 2 logs because it's addition. I can't do anything. So that's just 1/3 log base 4 of x plus 1. How about, okay, this is the one you were talking about.
Yeah.
This right here is an actual number. Good. What?
That's a 2.
What's this is saying 4 to what power? 16?
2
2? 2 times negative 1/3,
is 2.
negative 2/3.
2.
So that just turns into negative 2/3. I always like, when I do these expanding of logs, I always like to put one of them that's going to be a number.
I noticed.
Yeah, yeah.
So we can print.
Just so you're recognizing it when you see it. All right, the last one, can I do anything? No. Okay, so I'm done. Okay, box that up, that's the answer. That's expanded. Condensing is the opposite, right? I give you a bunch of logs strung out, and then you bring them all together into one. Do you want to see one of those? No? You're okay? All right.
I mean, as long as you don't give us one where we have to know where
You can do one, you
that
can do the other.
2/3 is. You know,
Oh, yeah. See, this would be hard to condense back. Pardon?
we said we
Where?
wouldn't give it.
This? That's the part, remember.
Oh, yeah.
You sure?
Yeah, I got it. Where you just.
You sure? Yes?
Yeah.
There's a bracket here. That becomes 2 logs, and then the negative 1/3 goes through both. Okay, good. All right. So find domain, inverse, expand, condense. Solve log and exponential equations. When's our exam? Thursday,
At
12:30. Right? Make sure you're fed. Make sure you're rested. Although you can sleep in the final. I don't mind if you sleep during the final.
As long as you don't smoke.
Yeah, just don't interrupt any others in the class. Solve log and exponential. What? Huh? Are we seeing this? Now, there's a variety of things that you could get when it comes to log equations. All right, there's a variety of things. But this to me is my favorite type, although putting a minus between those would actually be another type I like. How do you solve this log equation?
Well, you can combine it.
Combine those 2 logs together?
Hold on. Yeah.
Yes, that's good. That becomes a quadratic, x plus 1
All right.
times x minus 4
And then that's just a quadratic.
equals 2, right? Then the loop, good. This is where you do the loop. 5 times 2 is this?
No,
5 raised to the 2nd power, right?
Yes, it's that.
So we get 25 equals x plus 1 times x minus 4. And then you just set each of these equal to 25?
No, 0.
No.
So what you're going to do is you're just going to get whatever that quadratic is.
Expand it out
Right, expand it out, and then take this 25 over and set
like
it
that,
to 0.
and then bring your 25 over.
And it's just factor it or
Yeah, I'm going to make a problem on the test that's going to work out a little nicer than this. I just made this problem up. We could solve this though, right?
Oh, yeah.
Quadratic formula.
formula.
But I'm going to try on the test to make it factorable. But you should be prepared to use a quadratic formula. I mean, no student getting through Math 1414 should be like, man, I got to use a quadratic formula, man. This sucks. I mean, you should be like, yeah, no problem, whatever. It sucks, but I'm going to do it, you know?
Yeah.
Okay.
What he said.
All right, so ... do we have to check our answers for logs?
No. Wait. For exponential? No, yes.
For logs, yes, right?
Exponentials, no.
Exponential,
doesn't
no.
make a
So
difference.
here we're going to check them, and we got to make sure it's positive.
Right, as long as it's not negative.
No, positive. It can't be 0 either.
That's what I said, as long as it's not negative.
0 is
Or 0.
0 is not negative,
So,
but it can't be 0.
you know what I meant now.
You said not negative, but that means 0.
Not positive means 0.
Okay, fine, it has to be greater than 0.
There you go. There you go. I just want you to say it properly because you're thinking it right, but you can't include 0. So yeah.
Smell on your uncanny camera. This is not
All
the
right.
kissing.
What would happen if I change a problem to minus?
It would be dividing.
This would have been division right here, right?
Yeah.
Which means that when you got to this step, you would have been like this. And then you would have multiplied both sides by x plus 4. And you would have had a linear equation, would have been much easier to solve. Do you agree?
Yeah.
Oh, wait. Yeah, yes, you would.
So you're gonna put minus?
He said both of this.
They're both fair game.
So leave it blank.
All right. As far as an exponential,
Yeah, for yours he's gonna leave
I
it
like
blank.
what the thing like I put on your test, which is something like, I don't know, 9 9x minus 5 times 3, 9 to the x minus 5 times 3 to the x plus 4 equals 0. Solve for x.
That's what's gonna be in the test.
I mean, I like these types of problems.
Oh, I know what you're gonna do.
You do?
Yeah. so
What?
You're gonna get that, 9 down to the base of the 3. So it's
Good.
gonna be 3x squared.
Oh, substitute?
Yeah.
3.
Then you're, it's gonna be 3x squared. 3 to the x.
No.
3 squared.
3 squared raised to the
You can do this both. Okay, so let's talk about that. 9 to the x is 3 squared to the x,
Well, I wanted to also.
which is 3 to the 2x, but that's the same as 3 to the x squared. All of those are the same, right?
Well,
Yes.
Right, but I wanna do it that way so that we can do a substitution.
That's correct. All of these are equivalent, but this is the one you want
That one.
because that looks exactly like this, and then you can do a u substitution. So that's 3 to the x squared minus 5 times. I don't need parentheses around this, but sometimes it helps people see the substitution is 3 to the x. So I'm going to let u be 3 to the x. And I proceed to rewrite this as a quadratic. U squared minus 5u plus 4 equals 0. Does that factor?
Yeah.
You're welcome. U minus 4, u plus minus 1. And you get what? 4n1? 2 solutions?
Now you gotta, plug that back in.
Yeah, now you got to replace your u with 3 to the x. So 3 to the x equals 4, and 3 to the x equals 1. One of those you should be able to tell me the answer without doing anything.
The 1,
Okay, what's the solution here?
0.
0. X, 3 to the 0 is 1, right? What about this one?
That one, it's 3 to the 4, yeah.
It's what?
Exactly.
It's ugly.
Yeah.
This is ugly when that wasn't ugly?
That's gonna be 81.
81?
Oh, it's not good.
No.
3 to,
What are you trying to solve for?
3 to the 4th equals x.
What are you trying to solve for?
X.
Okay, where does x reside?
The exponent.
In the exponent. You don't want it there. Where do you want it?
down. below.
Down. How do you get things down? Natural log, exactly. Natural log of 3 to the x, what you do to one side, you do to the other, right? This look more familiar now? Drop your x out. X, natural log 3 equals natural log 4. Divide both sides by natural log 3, because that's multiplication. Can you combine these two together?
No.
No, you may not. That is not a property of logs. So that's your answer.
But what you can do, you can get that number and divide it.
That's right. You can get this as a decimal on your calculator. I would accept this, or I would accept the decimal. I don't care. But I need to see the work. What is it?
0.792.
0.792? That sounds about right. X equals approximately 0.792. The other answer was x was 0. So if we plug those numbers into this original equation, we should get true statement. Y'all doing all right? Because I'm fading fast up here. Solve log and exponential. Okay, exponential growth, decay, word problems.
Are you gonna give us that formula or the A9?
Sure, I'll give that to you again. What problem did I put on the test? I can't remember on the last test.
8.
Oh yeah, that's right. That was the, it was like a medicine, right? Like a medical, like a drug.
I'll read it.
That was, I remember what it was. But I had messed that up in class. Remember I had said that time always had to be in years, and I was confusing it with a financial equation. So time can be measured in
It
anything.
was the carbon half-life is what it was.
Yeah. So we'll do something in that. Just go back and take a look at your notes when I was doing exponential growth and decay word problems. Take a look at the problems I did in class. Newton's law of cooling, bonus problem maybe? That was a hard problem. Remember, I stepped out of class and I let y'all figure it out, and I came back and y'all were all pissed off because I was like, I didn't give you enough information, that we had to take the measurement at the second time. Remember that? That'd be more of a bonus problem.
You have on the bottom, I know we're not there yet, create formula for a sequence.
Yes,
We did last time.
we did that last class. But it says bonus down there, right? That's bonus material, so it's not on the test. Solve a system of equations in word problems.
As long as you don't give us that one where that 1, 2, 3, 5.
Oh, the Fibonacci sequence, yeah. How do you feel about that system of equations in word problems?
We just did that.
Weren't there some homework problems that were like that?
Yeah.
If you did them?
Difficulty with some of them.
Okay.
I can tell you one.
Okay, yeah, you can tell me one.
Um,
But before we do that word problem, let's talk about the last parts. Compute the determinant. Compute the determinant of a 2 by 2 matrix.
That's the one where you go
Cross, subtract. Yes, just be able to do that mechanically. All right?
You're just gonna give us a 2 by 2.
Give you a 2 by 2, what's a determinant? Now, I'm not going to say that problem's going to be worth a lot. Like, that problem is not equal weight to all the other problems, but be able to do it. All right? Partial fractions. What do you think about that? That's what we covered the last few days, right? Okay.
Oh yeah, that's the one where you give us the like what is
Yeah, like A over whatever, or, you know, A over B over this, or sometimes it was BX plus C.
I think it's fair. As long
Okay.
as it's not like ridiculous.
And you're free to use your calculator to solve that. I never heard from you.
On by one.
You're going to go get one? All right. Well, don't be like, hey, my teacher's telling us we have to buy it. I'm willing to get you one. But you got to learn it between now and then, too. You can't walk in here like 5 minutes before the final and be like, hey, can you show me real quick? Like unpacking it from the store, you know, like I've had people do that before. And I'm like, yeah, yeah.
I'll charge $1.
The bonus problem, I give you a sequence and ask you to come up with a formula. There were like common ones, like the evens, the odds. Then we could like move them around, and then we could do alternating,
Which one's?
like negative, positive,
Yeah, with
right?
that
Yeah, negative 1 to the n or negative 1 to the n plus 1. So that'll be a bonus. All right. See if you can do that. Now, word problem, system of equations. This will be the last thing I talk about. What do you have?
Number 67 on section 12.1.
12.1, 67.
If I remember, it's like a medical.
Restaurant management? Is that not right?
Some,
67.
yeah.
Restaurant manager wants to purchase 200 dishes? That's okay? All right. All right. I'll read the problem. 856, page 856, number 57. It says a restaurant manager wants to purchase 200 sets of dishes. I'm just going to jot this information down. 200 sets of dishes. One design costs $25 per set. Design A, $25 per set. Another is 45. Design B, $45 per set. Got it? If she has only, that sounds weird. If she has only $7,400 to spend, how many sets of each design should she order?
Yeah, that's why it's kind of worded cool.
Yeah, so I guess what we're trying to figure out is there a way to spend $7,400 exactly and have 200 sets mixed with A and B?
So A plus B must equal 200.
A plus B? Well, no, we have to write down what is A, all right? So we got to establish what is A. Make it clear to me what A is.
$25 a plate.
No.
The set.
Design A costs this much per set. You just told me that A plus B had to be 200, right? So A is not $25 per set. A is the number of sets, isn't it? Of A?
Oh.
Let's just be clear on what we're defining what to be. If I'm going to say A, what I mean is this is the number of design A sets, right? That I'm going to order. That's what I want A to be. And B, I want it to be the number of design B sets. At the end of this, it's asking how many sets of each do we order, right?
200.
No, how many sets of each do we order is what they want to know.
So then 25x plus 25y is equal to 7,400? 25.
Yes, but let's do the one before that. This number of sets plus this number of sets has to be equal to 200. So I know that much. A plus B must be 200. And the other equation is the cost, right? The total cost. How much am I going to spend on the design A plates? 25 times this number. 25 times A plus the cost for each B set is 45. That has to be equal to, I want to spend all my money, $7,400. And now you have your system of equations, which you can solve using substitution, elimination, or RREF on your calculator.
So I had it, okay, I don't know why I was so confused.
So if you're going to do RREF on your calculator, your numbers are 1, 1, 200, and then 25, 45, 7,400. Anyone get this yet? Yeah, let me see. The answer's probably in here. No. 12, 1. Maybe it's a weird answer. Okay, well, I'm actually just gonna work it out by hand, I guess. I'll just multiply this top one by 25. I'm doing elimination. I'm gonna clear out the A's. So I multiply the top row by 25. When I do that, negative 25. When I do that, I get negative 25A. I get minus 25B. And over here, this is what? What's 2 times negative 25? 50? So this is negative 5,000. Now we add straight down and get 0A, 20B equals 2,400. And so B is 120. And then to find out what A is, you go up there and 200 minus 120, you get A is 80. So A is 80.
Yeah.
So let's just check it real quick. If we add those up, we should have 200. All right. If we do $25 times each of the A's, right? If we do 25 times 80 and we add that to 120 times 45, whoa, I should hit multiplication. 7,400.
73 was strange because we gave you the formula, but then.
Yeah, you know what? I did that in class. Yes. Do you remember I gave us 3 points on a parabola and asked us to come up with the equation of the parabola? I remember doing it.
I remember vaguely. I remember
Yeah.
exactly where I was.
Yeah. I would refer back to a video of a lecture where it was when we were doing, right when we were doing the systems of equations where we had 3 equations, 3 unknowns.
Yes, you did.
You see it?
Yeah.
Yep. So follow that method.
Okay.
See if you can. Just go back and review. I can't do that in 8 minutes.
I know.
Yeah. All right, everyone. Do we have any other comments or concerns?